Okay, be with me for a second. Okay, yeah. Just getting this organized. Okay, yeah. Okay. Okay, what I want to look at is AC motors. One second. AC motors, okay? And what I've done is to, let me make sure that I can bring this up a little bit larger if need be. Wait for a second, let's bring it to 151. You shouldn't give me some opportunity then to do that. Okay. So we're looking at AC motors makeup and construction. Okay. And here we are. Okay. Now you have your enclosure, you have your stator, and you have your rotor. Okay. And this is your box where your three-phase system cabling connections will come into play. Okay. Now this is AC motor construction. Now this is asynchronous AC induction motors are commonly used in industrial applications. An asynchronous motor is one in which the rotor speed differs from the speed of the rotating magnetic field. In general, for AC induction motors, this means that the rotor speed will be less than the synchronous speed of the rotating field due to slip. Now, do a bit of groundwork for yourself on this so you understand the difference in regard to asynchronous and synchronous motors. Okay? Now, it's okay, my phone is just gone off and disturbing me. Okay? Now, we need to have slip in the motor in order for the motor to rotate. If we didn't have any slip, this rotation would not take effect because it means that there would not be a lag factor. Well, I call it a lag factor between the rotor speed and the magnetic field rotating. Okay. Now the illustration shows a typical three-phase 460 VAC asynchronous induction motor. Its three primary parts are the rotor, the stator, and the enclosure. Okay, and here you have them labeled unidentified. Okay. Now stator core. Now what we have here is a laminated stator core lamination, and we have lamination because we need to reduce the amount of eddy currents that could develop within motor. Okay, because if you have eddy currents, you're going to have a heat generated, and when you get heat in a motor, that is a bad thing because it causes the insulation of the motors to break down. Therefore your motor will burn out. So what we need to do is to ensure that we have good laminations to reduce eddy currents around the motor within itself. Now, stator core. The stator consists of a core made of thin stacked laminations that are wound with insulated wire. As previously described, when current is passed through this wire, the stator acts as an electromagnet. Several hundred laminations are stacked together to form the core. So even though we have one piece here, 700 of these could be stacked together to create that core. Okay, and each one will be separated and they will be pulled together by a bolt of some sort to hold them together, thereby reducing the eddy current effect. Okay. Now, and here we have, I'm hoping that you can see this quite clearly. Okay, just make sure that we can get it up. I'm never quite sure what to do with this. Get the best effect. Okay. Now, stator coils. Stator laminations are stacked together to form a hollow cylinder. Coils of insulated wire are inserted into slots of the stator core, usually along with stiff paper insulators, or paper insulation, or sometimes formica sheets might be used, depending, but then I'm going back a while. Okay. Here you have your stator core, and it's showing you here paper insulators. Okay, insulated wire coils. Now these insulated wire coils are actually kind of vanished. Well, I call it varnish, but they may call it something else. Okay, you can see that how that is being put together. Now, all this is done at a factory. Okay, it's not done on site. It's all done at a factory, and it's assembled at a factory. Okay. And here we have the finished job. Now this is the finished work. You can see the neatness of it and the professionalism that goes into this, creating this stator core. Okay, stator core insulated wire coils. Okay, each grouping of coils together with the steel core it surrounds form an electromagnet. The stator windings are connected directly to the power source. Okay. And here we have our rotor. The most common type of rotor is the squirrel cage, so named because of its resemblance to the exercise wheels found in the rodent cages. Okay. And here we have again, the rotor consists of a stack of steel laminations with evenly spaced conductor bars placed around the circumference. Okay, conductor bars slots. Now these here are bars. Okay, they're not cables as we saw a little bit earlier. Okay. 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 Here we have the cable type, but here you're looking at what we refer to as bars. And let me see if we go down. So you have your conductor bar slots, okay? Uh, okay, so I was just reading something here that I was hoping that it might give me some additional information, but it didn't quite work as I thought. It gave me something else instead. Okay, and here is your finished product. Okay, rotor, stator, and you can see that the rotor is consists of these iron bars here internally. Air gap. Okay, the air gap is between the coils and the rotor itself. There is a fine air gap between there. Okay, the enclosure consists of a frame or yoke, and two end brackets or bearing housings. The stator is mounted inside the frame. The rotor fits inside this frame with a slight air gap separating it from the stator. Now if the air gap did not exist, it means that they would both be touching, therefore the motor will not run. You simply burn out a motor, and that is no use to you whatsoever. So the air gap plays a very important part. There is no direct physical or electrical connection between the rotor and stator. Okay, air gap, and you have your cables coming out here. Okay, frame or case, I would call this the casing. Okay. Okay. Okay, I hope you found this useful. Let me see if I can. Let me see if I can bring you up. I could not emphasize these any larger. It didn't give me the opportunity to do so, but I'm hoping that this will be adequate for you to see and get the idea of construction of your motor. Okay, thank you. Hope you found this useful. Bye bye.